In this numerical 5.13, mass of a man 70 kg, right? So initially we have to find if velocity of that man which is in upward direction, what is the force exerted on that man, right? So see here, whenever velocity is constant, there is no need for any force. So at the first type we have force is equal to 0, right? Only we can say that only weight of that particular object which is in downward direction. So weight which is always non-zero, which is always downward direction due to gravity, right? Okay, now in second we have acceleration 5 meter second to inverse, which is downward direction. If acceleration is downward direction, its pseudo force is upward direction, right? So to write the formula for this particular incidence, R plus we have upward direction ma is equal to mg, right? So yes, R is equal to mg minus ma, mass common, g minus a, right? What is mass? Mass is 70, g is 10, minus 5, so our answer will be 7 5s are 350 Newton, right? So answer will be 350 Newton here. Okay, now we are moving on to our third types. Acceleration we have that is in upward direction, that means pseudo force is downward direction, right? So starting from this formula, R minus ma is equal to mg, so R is equal to mg plus ma. So here 70 in the bracket into 15, right? So 1050 Newton is the force exerting in downward direction. And the last case, which is motion, means if man just falling freely. So if man just falling freely, then our pseudo force is, for example, gravitational force, we know that 10 meter second to inverse, which is downward direction, right? So here see, pseudo force which is in upward direction, so R, then here plus mg is equal to mg, so R is equal to mg minus mg, so that will be 0. So whenever if any object is under the gravitational force and it is free falling, then no other force will be working on that particular object. Numerical 5.14, right? So here we have position time graph of a particle of mass 4 kg. So first of all we need to find force on the particle for t less than 0, t greater than 4, and 0 to 4 second, in between this 0 to 4 second. And then we have to find impulse at t is equal to 0, t is equal to 4 second. Okay, so starting from force, yes. So as we can see in this figure, up to 0 to 4, we can see distance is directly proportional to time, means we can write velocity for 0 to 4 second is constant. 0 to 4 second velocity will be constant, right? So 1 second. So here again I am writing velocity is equal to constant, right? Okay, if velocity remains constant, so first of all t less than 0, as we can see t less than 0, no graph is just formed by t less than 0, that's why force will be 0. If there is no displacement, our object will be at rest, that's why force is 0 for t less than 0, right? Okay, then t greater than 4, again position remains constant, so our object is at rest greater than 4 seconds. Similarly, if object is at rest, then again net force will be 0, that's why object remains at rest. So this is for t greater than 4. Then 0 less than t less than 4, right? So see here, again velocity is constant, and whenever velocity is constant, force will be 0. Okay, so no force from 0 to 4 and greater than 4, right? Okay, then now we need to find B, impulse at t is equal to 0. So we have to find here impulse. What is impulse? Impulse is change in momentum, means delta p, right? So delta p is equal to, we know that, mass common final velocity minus initial velocity, right? This is our final velocity, like this. Okay, so yes, final velocity. What is our final velocity from 0? If we are talking about for 0, so mass always remain constant 4, right? Then v, see here, final, to find final, we have to find slope of this graph. So what is exactly slope? Slope is equal to y-axis upon x-axis. So y-axis, that is 3, and x-axis, that is 4. So this slope just denotes velocity. It is final velocity. So I need to write final velocity here, 3 by 4. And initially the object is at rest, so that's why 0. So 4 gets cancelled out. So we are left with 3. So our impulse is 3 kg meter second inverse, right? That's our change in momentum. Change in momentum is our impulse. Okay, so now we need to find impulse at t is equal to 4 seconds. So for t is equal to 4 seconds, again I am writing that formula, similar formula, delta p, again similar m, now final minus initial. See here, at t is equal to 4, right? So 4 into, what is our final? Final, our object remains, our object distance, position remains constant, right? So that's why I need to write here 0 minus initial. Now initial is at 4 seconds, right? So we can write here 3 by 4. So yes, 4 gets cancelled out, and now we are left with minus 3. So that is our change in momentum, which is called impulse, right? So that's it. In this numerical, we have this system force which is exerting on any object, right, which is 600 Newton. Now our A block have mass 10 kilogram, B block have mass 20 kilogram, and in first case we just put some force on A block, right? So we have to write here free body diagram. So that starts from yes, MA is equal to force which is in right hand side direction and tension which is exactly on opposite to it, right? So see here, tension T. Okay, so mass into acceleration, but this is for only one, so m1 into A, right? So first of all we need to find A. Okay, so A is equal to total force upon total mass. What is total force? 600. Total mass 10 plus 20, it is 30. So cancel out, we get 20 meter second to inverse here. So from this we need to find tension. So T subject, now F minus m1A. Okay, so what is force? 600. 600 minus what is m1? m1 is 10. 10 into 20. So our answer will be 600 minus 20 into 10, 200. Answer will be 400 Newton. So for first case, now we need to find for this. Similarly, see, now force exerting on B. So m2A is equal to, on for B, is equal to same force minus same tension. Again we have to find tension. So T subject, T is equal to m2A, that's our minus m2A plus F, right? So now we need to just put all the terms. m2, that is 20, acceleration 20 again, plus force is 600. So yes, 600 minus 400, answer will be 200, right? So for this case our tension will be 200 Newton. In this numerical 5.16, right, we have this system. This is 8 kilogram, 12 kilogram, right? They are joined with one string. On the string, obviously tension will be produced, right? So starting from, we have to find first acceleration of the system and then tension on this string, right? So yes, now first of all we have to write free body diagram for this particular object. So starting from it, now the first formula, we have that first formula, which is T minus weight is always downward, so m1g is equal to m1a, right? So that's our first formula. Now second formula, so we need to write for this, see here it is upward, but if we are going in this direction, so this is in same direction, but if we are going in this direction, this is of opposite, so that's why I have to write minus t. Then in this direction similar to weight, so that's why I have to write plus m2g is equal to m2a, right? Okay, now to find acceleration here, just subject t is equal to m1a plus m1g. Here t subject, then we get m2g minus m2a, right? Yes, so now just put this formula here, right? So m1a plus m1g is equal to m2g minus m2a. Okay, now we need to find acceleration from this formula. Okay, so just put the acceleration term in one side, so m1a plus m2a is equal to m2g minus m1g, right? So here from this a common, m1 plus m2 is equal to g common, m2 minus m1. So acceleration subject g m2 minus m1 upon m1 plus m2, right? So by putting all the values here, 10, what is m2, 12 minus 8, that will be 4, 12 plus 8, that will be 20, so 40 upon 20, that will be 2 meter second 20. So whole system has this acceleration, right? Now we have to find tension. So take just any formula from these two and then put all the values, that t is equal to m1. What is m1 here? 8, acceleration 2, plus m1 8, acceleration is 10, right? So 8 to the 16, okay, 8 to the 16 plus 80, so our answer will be 96 Newton. So in this question, for a nucleus in a laboratory, when it's disintegrate, right? So law of conservation of momentum is followed by that nucleus, right? So see, whenever that nucleus it is at rest, momentum will be 0, right? When it disintegrates, if the fragments of nucleus, that we have two fragments, right? So we know that m1 v1 plus m2 v2, right? So these are the two fragments. Now that fragments just behaving like that, one fragment's momentum, other fragment's momentum, these momentums are exactly opposite with each other. That is how they were disintegrated, right? So if that happens, that will be 0, the algebraic sum will be 0. That means m1 v1 is equal to minus m2 v2. So if we find v1, then what happens? Minus m2 v2 upon m1. So this theory gives nothing but just tells us that the law of conservation of momentum anyhow can be followed by any particles. Like here, before any process our momentum will be 0. After that process our fragments will move like that, their algebraic sum of their momentum will be 0. In this numerical we have two billiard balls. These balls initially they are before that collision, their momentum, so initial momentum, mass into mass into speed, right? So 0.05 into 6, simple. So here we get that 0.05 into 6, we get 0.3 Newton into meter, right? So that's our initial momentum of this system. Now after colliding with each other, their final momentum will become exact opposite with each other because they are same. So that's why they, after collision, they gets opposite direction. That's why after collision we need to write negative here. So we get minus 0.3 Newton into meter. So if you want to find change in momentum, delta P is equal to final minus initial. So we get minus 0.3 minus 0.3. Answer will be minus 0.6 Newton into meter. In this numerical, we have mass of gun, mass of shell, muzzle speed of the shell, and we have to find recoil speed of the gun, right? So simple again. This is the question of conservation of momentum, right? So see, initial momentum means gun momentum is equal to final momentum, which is of shell, so m into v, right? So we need to find v is equal to mv upon capital M. But here we need to write negative sign because this negative indicates that recoil speed of the gun is exactly opposite to the speed of the shell. So their direction are completely opposite with each other. That's why we need to write here negative. So starting from 0.02 into velocity, that is 80 upon 100. So 0 gets cancelled out. So here our answer will be 8 to the 16. So 0.016. That's our speed is in meters per second, right? In this numerical 5.20, right? So we have one object which is just about to collide on this wall. After that it just move in this direction, right? So incident and reflected, the angle between them is 45. So we can divide in half 22.5 and 22.5 like this. Okay. So yes, that object mass, that ball is 0.15 kg. Velocity of that particular ball is 54 km per hour. So we can convert it into meter second inverse by to multiply 5 upon 18, right? So we get 15 meter second inverse. Now we need to find impulse. What is impulse? Impulse is exactly change in momentum, right? So see here, if I am drawing the projections of this particular ray, we get horizontal and vertical like this. Same, we get vertical and horizontal like this. So you can see that here, if you are talking about only horizontal, this is left hand side direction, this is right hand side direction. But if you are talking about vertical, their change will be 0. Why? Because they are in same direction. So for same direction, this minus this gets 0. So we need to talk about only these terms. This right hand side, this left hand side means final we have in left hand side, right? That is minus initial, that is plus. So if I am writing that formula here, delta P will be final, which is minus mvx. We need to write here x only. So minus mvx cos 22.5 minus initial, which is in right hand side direction, so minus as it is, and here mvx cos 22.5 degree, right? So here summation of these two, minus 2 mvx then cos 22.5 degree. Okay, now we have to put just all the values here. So 2 as it is, right? Mass is 0.15 as it is. Then Vx, right? So Vx, from here we get that. So put it here. Vx as 15 and cos 20.5, that you need to find from that cosine table. Whatever that value, you need to put it here, and then you can find impulse by the way to find change in momentums. In this numerical 5.21, we have stone mass 0.25 kg, right? And radius of that circle. So here stone is moving in circularly, and that stone path radius is 1.5 meter, right? So here they have given number of revolution per second is n is equal to 40 by 60. So actually that's our frequency. We can write f also, 40 upon 60. Okay, so yes, starting from omega formula is 2 pi nu or f or n. So 2 into 3.14 into that 40 upon 60. So then we find here omega, which is in radian, right? Now we need to find tension. See here, tension. So to rotate, to move that stone circularly, the condition for that tension should be equal to centripetal force mv square upon radius, right? So T is equal to m. We need to convert this V in the form of omega. So that formula that we have, V is equal to, I am writing here, V is equal to R omega. So this formula here for 22 and 23 numericals you need to do in your homework.